Every day, the average person consumes 2,000 calories to sustain themselves. To put this number into perspective, 2,000 calories is equivalent to 4.2 pounds of apples, 1.7 pounds of rice, or 1.2 pounds of steak. So where does all this food come from? Roughly 15% of all US food is imported from other parts of the world, such as Asia and South America. This is because of either favorable growing conditions or lower costs of production. The majority of red meats, grains, and vegetables are grown domestically, with California being the largest producer of the 50 states. This means that the food we buy has traveled hundreds, if not thousands of miles to reach the shelves of our local store. To help exemplify some of the problems with this system, let's examine grapes. Many of the grapes that we eat are grown in Chile, roughly 5,000 miles south of Los Angeles in South America. This is because of the favorable growing climate and low cost of production. From where the grapes are grown in Chile, they must be packaged, freighted to a local port, shipped to the US, freighted to a distribution center, stored in a warehouse, freighted to a local store, bought by the consumer, and then finally driven home. Each of these steps drastically increases the amount of energy used, as well as the amount of pollution expelled. Now let's look at a model where the produce is grown locally. From the farm, the grapes are picked, freighted to a local store, bought by the consumer, and then taken home. This model is far more efficient and less harmful to the environment. The only model that is more efficient is when consumers grow their own produce on an individual basis. In this model, food travels directly from the source to the consumer with no extra infrastructure needed. The problem with growing locally or individually is that the urban environment is generally unsuitable for agriculture. On average, it requires 1.2 acres of cropland to sustain a single person. By thinking about acreage in an urban environment three-dimensionally, we can find large amounts of space suitable for agriculture. Plants can be grown on the tops and sides of buildings using hydroponic systems to provide the necessary water and nutrients. This technique is known as vertical farming. By integrating food production into the built environment, the remaining agricultural land on the site can be utilized to support other needs, such as orchards and meat production. By utilizing these techniques, PostOP has the potential to be self-sustaining for the vast majority of its food needs. By doing so, it decreases environmental impact and increases the health of the community's residents. These systems are therefore an indispensable element of the PostOP framework. Despite the benefits of the elements proposed for PostOP, none of them would be viable without an economic engine to provide financial income and local employment opportunities. The bioplastics manufacturing facility has been included in this project to fulfill that need. Bioplastics are a type of polymer derived from organic matter, primarily plant materials containing high levels of starch. Some advantages of bioplastics over traditional plastics is an 80 to 90% decrease in CO2 emissions during manufacturing and complete biodegradability. In addition, as with locally grown food, the use of these products within the site would mean far less energy being spent on transportation of goods. The manufacturing facility would obtain the raw materials necessary for plastic production from both the agricultural land on the site as well as this vertical farm facility. Overall, the facility would be able to provide roughly 500 jobs and produce over 100 million pounds of plastics every year. By capitalizing on local crop production and manufacturing, PostOP could become primarily self-sustaining and would be able to better fare economic crises while minimizing its environmental impact.